Okay, class, today I'm just going to show you guys how to set up force diagram for ramps. It's actually quite easy. You just got to get a couple of things straight, and then I'll show you how to set up your Fnet equals MA for your vertical and horizontal forces. The first thing I want you guys to know is that when we're dealing with ramps, that when we're looking at the horizontal plane, horizontal is going to be along this axis, parallel to the ramp. So I'll call that horizontal. And then vertical is going to be along this plane. Now, I know they're both angled. This is how we're going to define it. Okay. The first thing that you guys are going to have to do is draw the force of gravity going straight down. That is really easy. I tend to draw that right there and label it on the left side. That's going to make it easier on us in a little bit here. The next force is going to be the friction force. And this is easy. You guys would just point your force the opposite way, parallel to the surface. It's the ramp trying to slow down the block as it accelerates down the ramp. We also have our normal force, which is perpendicular to the ramp, pointing up and to the left. Now those are the three forces, but because this is a ramp and it's angled, the force that gets broken up into its x and y components is the force of gravity. So there is one way that I really like doing it, and that's what I'm going to show you here. The trick to doing this is to actually have the force of gravity be split up into its vertical, that, and its horizontal components. Now we could get into the geometry of it, but like we'll find out in class, is that the angle theta here is always going to be the angle theta there, always, 100% of the time. I'm sure we could go ahead and prove it with geometry, but we don't have to do that now. Now, these two components, this is the force of gravity, and because that's touching our angle theta, that's going to be Fg cosine theta, and this is Fg sine theta. It is opposite of our angle theta. Once you have this set up, if you can remember how to set this up like that, it makes the problem so much easier. I always remember that sine points downwards. S is sine, and that's sliding down the ramp. The sine is always pointing in the direction of the block sliding down the ramp. So when I have you solve for anything in these problems, this is always going to be the way that you're going to set this up. So you're going to have vertically, you're going to have Fnet equals MA, and then we have these forces in the vertical plane. So when you set up your problem, you're going to have Fn, and because Fg cosine theta points the opposite way, you're going to subtract them. And you solve the problem like this every single time. Now Fn and Fg cosine theta are going to be equal. So you could even change the order of these, and it's not going to matter because this acceleration is always going to be 0 meters per second squared. Because the block is always going to be on the ramp. It's never going to come off the ramp. Vertically, the acceleration is always going to be 0. But horizontally, now I've got this force and I got this force. We broke this Fg up. We no longer have to use it. So now when we go and we solve for our forces and we start with Fnet equals MA, now we've got two forces, Fg sine theta and Ff. I prefer to consider Fg sine theta in the positive direction going down the ramp because that's going to be greater. The block's not going to, friction's not going to accelerate the block up the ramp. So I consider Fg sine theta to be a greater force. So I put that in the positive direction and then subtract off friction in the opposite direction equals MA. And now this acceleration right here may or may not be 0, just depending on the situation and the problem. Anyways, that's how you set up the problems. That's how you set up the force diagrams. That's how you set up the vertical and the horizontal forces. At this point, you can now go to the problem, insert the correct information, and solve for what you needed. I think that's about it. Thank you very much.